Welcome back, COP 1000 students. Dennis here. Module 11, Hodgepodge of Things. What I'm going to do here is just go through some various topics that we've kind of brushed over. First one is defensive programming. Defensive programs or defensive programming, depending on how you look at it. So as a programmer, you're in control of what happens and goes on when you're within your source code. But once you give the program to a user, you're out of the picture, you're out of control. You can't really know what that user may or may not do. Defensive programming is about stopping a user from doing something bad. For example, maybe inputting a value outside of a range that you would expect. The easiest way to write a defensive program is to take a valid block of code and make it the body of a while loop. Make the user stay in that while loop until they enter what you're looking for. Remember that there are, I don't know why that happened like that, but there are 4 different data types: int, float, string, and bool. Int, float, string, and bool. Come on, stop it. And I'm assuming you know what these stand for and what they do. So let's talk about a flag. Not this kind of flag, but a flag used by a programmer. So a programmer uses a special variable that could be called a flag variable. This flag variable uses a flag when the user does something. For the record, there is no such thing as a flag variable, but there is using a variable to flag an event. So we'll use just any old variable of type bool typically to flag when something happens. Remember, bool values are quite often used when we define flags. Recall that the value of a bool variable can only be true or false. And notice that word true, the way it's spelled, capital T, capital F, all lowercase letters in both those words. That is the syntax of true or false in Python. So let's assume we're going to validate the range of an integer. So assume you ask the user to enter a number between 1 and 10. Between 1 and 10, not 1 and 5, 1 and 10. You need to make sure they enter a value between 1 and 10. So the first thing I did is created a variable called invalid, and I set it equal, or I assigned it to the word to true. True. And this variable, since it's true or false, is actually a condition all by itself. So to make this loop, or what I call prime this loop, I set my loop control variable to true so that I got in the loop. I asked the user to enter a number between 1 and 10. That value is stored here as an integer. If they typed anything less than 1 or anything greater than 10, then that would still be an invalid. So that would be true. If value is less than 1, say it's 0, then it's true. And if it's true, I say invalid. You need to enter something between 1 and 10. I'll talk about this later, but I'm going to pause the screen so they can read it. Otherwise, if this is not true, that means the number they did enter is between 1 and 10 inclusive, and therefore I throw the flag to false so that I get out of this loop. Remember, the user stays in this loop until he or she types in the values 1 through 10. I can do the same thing validating a string. So here's the same flag, here's my same loop, but this time, check this out, I am getting a character instead of a number. So I'm actually getting a string. I'm looking for the user to type in A, B, C, A, B, or C. And here's some new syntax. This is new. You can add the in clause as your condition in an if statement. This condition is true if the char variable, the variable char, is A, B, or C. In this case, capital A, B, or C. So I could just list a domain of things I want this to be inside of. In other words, A, B, or C, and it works. So if this char variable equals A or B or C, then this would be true, and I would throw the flag to false. Otherwise, I would yell at them, let them read it, and they would be stuck in this loop until they enter A, B, or C. Okay, next topic in my hodgepodge is formatting a floating point number, for example. So here is three variables, float val1, val2, and float result equals 98 point something, and so on and so on. So if I print this out, I'm going to get that, and whatever the division is. But sometimes I don't want to see what I'm looking at here. I want to maybe round it to 2 decimal places or 3 decimal places. And this is exactly how you do it. You're going to say print whatever you want inside of your format string. But inside of my format string, this is my formatting area. Inside of a left curly brace and a right curly brace, I'm going to start with a 0 colon. The dot 2 is after the dot 2 decimal places, and treat this as a floating point number. Dot format. Now, dot format is a part of this, and you'll get used to this if you practice it a little while. This float val will go inside of these double quotes as this prints. Same thing for this one and same thing for this one. Now let's look at this last guy. This last guy, notice it's 0, 1, and 2. So 0 colon, 1 colon, and 2 colon. Well, when I have a list, we always start counting in programming at 0. So this is the 0th thing, this is the 1 thing, and this is the 2 thing. So when I print this, I'm going to get this rounded to 2 decimal places, then this rounded to 2 decimal places, and then this rounded to 2 decimal places. In summary, defensive programming is stopping the user from doing anything bad. A flag is a bool variable to flag an event as the code is running. While loops are used in validating, you can use the format function to change the appearance of output. Notice there are many other forms of this format function. Just ask the Google. Okay, so now I'm inside of my IDE. Here's the code that we just saw in the slideshow. And I'm going to run it. And when it runs, if you remember, it says enter a number between 1 and 10. So let's say I type in 999. It says invalid input. I said enter a number between 1 and 10. I press any key to continue. It asks me again. If I enter a negative number, invalid, I press any key to continue. Eventually, I enter a number between 1 and 10. And it moves on to A, B, or C. So let's say I type in a little a. Well, a little a is not equal to a capital A, capital B, or capital C. So it yells at me and says, I said type that. And eventually, if I type in a capital letter, A, B, or C, it ends. Okay. Let me show you this piece of code. So this is the value of the of val1. I'm sorry. Let's take a look at the code up here. So this is value 1 out of this print statement. And notice it used to be 98.4583. When I ran it, it was 98.46. 98.46. So it rounded up. This next guy, 43.443323, was rounded to 43.44. And this last result, this is the math behind this. So this is what float total would look like. That's going to be rounded all the way up to 27. And when I do this very last statement where I print all 3 things across the board, here it is, 98, 43, 27. Pretty cool stuff. And the last thing I'm going to tell you is why this is staggered like this. Before the dot 2, I had the option to putting a width to the left. So for example, I put no width. Watch when I run this, they're going to be lined up. They're going to be lined up. Type a valid number. I'll type a valid letter. And notice they're all lined up. So I'll put a width behind the second one. So I'll just go 5. So the second number is going to have these 2 plus padding of 3 when it runs. Let's watch that run and see what happens. So I'll enter a valid number. I'll enter a valid letter. And that didn't happen. Notice I changed this to 15 because 5 is the default. 1, 2, 3, 4, 5. So this is a total of 5 spaces. When I made it 15, this jumped in to the right. Okay, I guess I'll see you in the next video.